Assalamu alaikum. Good morning. First of all, before I start, I would like to thank TRA for the wonderful opportunity that's giving to me in order to exchange some ideas and some thoughts about artificial intelligence. And thank them also for the great platform that is enriching the education in the UAE. My name is Ahmed Muammar. I'm a director of technology consultants in the UAE for Dell Technologies. Just a snippet of my background, 20 plus years of technology and leadership. I have an MBA on big data thesis focus, which is related to the topic that we are talking about, and a bunch of other certification from deep learning, Stanford University, AWS, machine learning, and big data. I have a wonderful, talented team that can help you to navigate through your journey in artificial intelligence and big data. Having said that, let's start. So when we talk about the artificial intelligence, some of us get that really passionate mood of this little girl. Tell me more. I want to know more about artificial intelligence. I want to understand what is the art of possibility when it comes to artificial intelligence. Unfortunately, for some of us, this is what we get when we hear about the artificial intelligence. In the sad news is, although it's a fascinating topic, it's a lot of interesting things, a lot of capability that can be done in the artificial intelligence. But the reality is, everybody is looking at it from its angle. The famous story of the blinds and the elephant, everyone look at it from different angle. For example, the business people want use cases, how it helps me in my business. The CIO might look for integration capabilities and what we can integrate from data perspective across the enterprise. Security team is very concerned about the data quality. Where did it start? Where it's going? Who has access to this data? Data scientist team want more data. I want to see more data. I want to improve my model. I want to get better in prediction. And the operation team is worried about the scalability of the model, how we can deploy it, how we can maintain it, the security around it. So everybody is looking at the big data, data science, and artificial intelligence from its angle. One challenge as well is that if you look at this slide, it's created by Mark and it's being created every other year since I think 2016. It just drew the landscape of big data. Companies that's providing services and technology in the marketplace. Some of them is concerned about data governance, data integration, others infrastructure and analytic machine learning. Some of them are use cases like healthcare or IoT. So the spectrum is very wide and everybody is explaining the data science from its view of how the data, how the technology will look like. So that's the technology view. But if you look at it from business view, and if I ask that question, I ask all of you, do we need analytics strategy in our organizations? I bet many of you will say, absolute yes. And by the way, gentlemen, ladies, if you have any comments, please put it on the comments at the YouTube, and I'll try to look at it every meanwhile to answer your questions. So, do I need analytics strategy? I assume most of you will say yes. And I have the same answer. But when I asked that question to my mentor during the MBA big data thesis, I asked him this particular question, and it was an eye-opening answer. He said, Ahmad, there is no such thing as big data strategy. There is a business strategy embedding big data. Don't talk to me about AI, big data. No, there is a business strategy embedding big data. And that had to be across all the value chain of data. While I'm not necessarily agreeing with the statement, but it's an eye-opener. Some people are looking at it from the famous framework of strategy analytics. If you look at the left side here, the famous 5 forces for Michael Porter, how these forces impact every industry. If you think about the aviation, there is the suppliers, oil prices, etc. As these forces increase, the profit of the industry decrease. So oil prices will reduce the profit in aviation. If the buyers like us, the customers, can switch between airlines, then yes, we can impact the prices of the tickets. So they will reduce the prices. So the more of these power, the more you get actually less profitable business. So that is if you look at the industry. If you look at the company itself and the value chain, and that's again Michael Porter value chain. If you look at it, there is the inbound logistics, there's the operation, outbound logistics. This is how we do business, HR, procurement, and then to create a value to the end customer. Well, in the data space, you need to look at all of these value activity and find out what data can be created and what insight can be added to this. Same thing in the competitive strategy, same thing in the value chain. And my MBA Big Data was about something called KPI or Balanced Scorecard for analytic or for companies. So a Balanced Scorecard for Dr. Kaplan is the same thing, measuring the performance of the organization. And while you're measuring this performance, the word performance by definition creates data. How can I measure the data? How can I capture the data? So again, artificial intelligence, we need to think about the business perspective. One view. I'm sure many of you will recognize this diagram, or that's ITIL version 4, service value chain. If you look at the people, the organization, the information technology, the partners, suppliers, value streams, all of these are creating kind of data. How can I capture the data? Intentionally thinking how to get the data in order to create a value for my customers. How my products can create and capture data. And we are hearing a lot about the IoT and how they capture data from everything. The services, how can I capture the data? And then I create insight out of this data. Different view, IT-centric. And I got a slide from Gartner. It's called just for a framework of applying AI in the enterprise. So if you look at it, it's a bit busy slide, but if you look at it in a very high level, the left side of it is focusing on the technology itself. So what AI can do as we have now, the capability of the AI, whether it's a virtual assistant, predictive analytic, fraud management, automation, etc. And then what is the technology supporting it? But in the right side of it, it's very similar to the previous slides. The value chain activity, HR, marketing, sales, and the competitive differentiation, Michael Porter 5 forces. And all of this, we need some use cases to support our business. Moving forward, well, a lot of people are talking about the use cases, but to be quite honest, for AI, I think of it as use cases agnostic. The limitation is your imagination. Healthcare, transportation, retail, healthcare. Today, for example, in COVID-19, people are getting MRI images to predict if this is pneumonia or this is a COVID-19 or something else. Financial, fraud management, risk management, all of this, something happening in the AI space to predict what the future looks like and what we have. In Dell Technology, we also have our methodology because the number of use cases is limitless. There are many thousands of use cases that you can put in your enterprise in order to understand the value of the big data. So what we do is something called Big Data Vision Workshop or AI Vision Workshop, where we list those use cases. We ask people to imagine, and then we see what is the business value of every use case. But at the same time, we look, can I really deploy it? So is it feasible to deploy it? And we put it in a matrix, and then we prioritize the use cases. So we say, if it is easy to implement and have a business use case, then please execute it right now. If it is a bit difficult to implement, it will take time, but it has a huge value, then you go to long-term version. We also like to think of data organizations in maturity. People start by monitoring some KPIs, moving to business insight, to business optimization, to data monetization, all the way to maybe go outside the scope of the business. So what we're trying here is to get into the essence of AI and the data analytics. Going to basics is always helpful to put a framework of thinking. So in Dell Technology, from technology perspective, and you have seen this line, a lot of moving targets, moving parts, how we can combine all of this together. We thought of it, would it be nice try to support the data scientists, get any framework that they want. Data scientists like to work with TensorFlow, PyTorch, or maybe Fast AI, and then they combine tools from here and there in order to run their model. But the problem is for IT operations, I cannot sustain it. It's a lot of tools, a lot of versions. How can they work together? How can I deploy it? I do care about making sure that any model, any data science model is scalable. The configuration management is a challenge. The security is a challenge. How can I do that? So we thought of it that we want to provide a platform, self-services, trusted, secure, and simple to deploy, reliable, and we created something called Ready System or Ready Architecture. So you get all the software or many of the necessary software that you need as a data scientist, as well as the hardware combined in one platform where the IT operation will be very happy to support because they know it works. And we combine actually the deep learning, machine learning, and sometimes the HPC in one reference architecture. So let's go to basics and simplify the idea. And it's very important to go a little bit academic and have the definition, because people are using the terms in different way. And I don't think the terms is very important now, but when you talk to academic or data scientists, they have something. When they say AI, they mean something. When they say ML, they mean something. When they say deep learning, they mean something. So in a very high level, artificial intelligence, think of a computer acting like a person. It can sense, it can reason, it can act and adapt. A computer like a person. In the machine learning, it's algorithms that's trying actually to create some insight from the data without being explicitly programmed. I don't put a program, and we will go through this. Now, deep learning, remember that. Deep learning is a subset of machine learning. The difference is it's implementing something called neural networks, huge and massive network of compute that actually can predict the data and maybe classify the data that it is coming to. So deep learning is a subset of machine learning, is a subset of AI or artificial intelligence. Nowadays, many people actually, when they talk about artificial intelligence, they mean deep learning. But in academically speaking, there is a difference. So I thought of bringing an example that's common for everybody, back to school. Right, everybody is missing the school nowadays. Parents are missing the school for obvious reason, and the students are missing the school to meet their friends, etc. So let's go to school and see this school which has taken a journey in the big data and data analytics. If you think about schooling system, it's a lot of actually systems running there. You have the curriculum, you have scheduling, you have the e-learning, you have transportation, and you have the IT, attendance, and grading, and the extra activity. You have the parents' relation, you have the IT, and you have the healthcare. And by the way, there is a student also who is very important in the school. So all of these systems are logging data. Now, assuming I am the dean of that school or the head of that school, and then I want to understand what is the average commute time for the students, and is there a relation between the commute time and the results? Well, I have a lot of systems. So I have exam results. We call these operational system. We have the attendance. We have the transportation. We have many systems. But the thing, they are different systems. And in order to find the results related to the transportation, I need to do some sort of data integration. So I need to extract the data from the source systems, the exam results and transportation, maybe do some mapping, like, for example, exam results can have a header called F_name, but the attendance and the transportation has first_name. Maybe it's just one name, and I need to split it to first name and the comma family. Instead of one column, I wanted to do two columns. Maybe the time in minutes, I want to move it to hours. So this process called ETL, extract, transform, and load. I extract the data, and there are many vendors out there, Informatica being one of them, and definitely Dell Technology, Boomi, and Spring Cloud Data Flow, and other vendors definitely play in that space. Then I want to put it in one system. We call that system data warehouse. it's a single version of truth. It's an aggregate of all of the data, collect all of the data from all source systems, and then move it to one place for the sake of analytic. And we have a lot of vendors in that space, including VMware, Dell, Pivotal, Greenplum Database, Teradata, Oracle Exadata, and others. Once I have this data, I can query it, I can visualize it, I can have bar chart, pie chart, and there are a lot of cool vendors out there like Tableau, Kibana being open source, and others. And we're seeing also that there are caching layer that people are doing there. Think of Excel sheet. When you open Excel sheet, a pivot table, and you want to dice it and slice it, it takes time because there is a lot of data to manipulate. Imagine if you have massive amount of data. So I put caching layer, and this caching layer today, example, a Presto database can connect to all of these in order to cache the data for you to do some dicing and slicing quickly. However, to be honest, most of these data warehouses have kind of a caching to help you do this. Now, so now the school has an understanding of the commute time as well as maybe the results of the students in the school. But now the question is different. Who are the students who will most likely pass? Listen to that question carefully. It's a future-looking question. It's asking about future, what might happen. It's a prediction. What we have done so far is a descriptive analytic. Now we're trying to predict what might happen. And here we get into what data mining is. Data mining is trying to find, I have data, and I need to look at patterns in the data to predict the future. Famous SAS, SPSS for academic people, and more often now than ever, we are seeing people are using RStudio to do some data mining activity. And data mining is correlated with machine learning. So I need to differentiate between the two. All of us at a certain point of time in our life, we did some programming. I did it in Fortran long time back, but C++ came and Visual Basic, etc. And what we used to do is we have data in the form of variables, maybe in files, and we have rules, the control statements, if statement, until, while, go to, etc. We process the data to create outputs. In machine learning, it's different. In machine learning, I have data, and I have the output, and I'm trying to create the rules out of it. So let's take an example, traditional programming. Attendance of students is 10 out of 10. Historical grade, which stands for H, 80%, like that's like 4 years average of data of achievement is 80%. And then the student, he or she is taking 8 subjects. So as a traditional programmer, I will put an equation and say, you know what, if I multiply 3 times the attendance plus 5 times 80%, which is 8 minus 8 subject, if it's greater than 45, then most likely the student will pass. This is what we used to do in traditional programming. Now in machine learning, it's a bit different. I will put data, output, and predict. So I'll put the previous historical data, like this student, 10 out of 10 attendance, 80% history, and 8 subjects. And this student, historically, he passed. The other students have different category, etc. So I put it in a model. I will try to do a training, and this process called training, to create the rule, data inputs, outputs, and then I'm creating the rule out of the model. Once I have the model, which is very similar to the one that we created previously, then what to do with that? Well, I want to do something in future data. So this process called training, which is basically data output as an input, and then I create the rule, we call this training. Now I take that model and I deploy it. This is why we call it deployed model. And what we do here is basically we get a new data and predict based on this what the student will have. Will he pass? Will he fail? So the student's 90% history in 10 out of 10 attendance and 6 subject only, definitely he will pass. We call that inferencing. And for this particular problem, pass and fail, we call it classification. So I'm classifying 2 categories, pass and fail. I can take the same model, but this time I want more or different view. I want to predict actually the score, whether he would get or she will get 80%, 60%. So I'm putting the data, same thing, attendance, history, and number of subjects, and I'm creating some sort of average. I put it in the model, I create the model, I deploy the model. When I have new data and new student, I'm predicting that student will get 86%. I'm getting linear here, numbers, and this is, we call it regression. So let's go back to our lovely slide. Systems, ETL, extract the data, putting in the data warehouse. I'm visualizing it in a Queen and presentation layer, but also I'm doing some data mining. Now, what's happening in most of the enterprises that some business units want specific answer. They are not waiting for the data warehouse, and I have to highlight that data warehouse is a long-term project. 80% of the time, just extracting the data. So the marketing is in hurry. I'm not interested in all the data, the single version of truth across the enterprise. I'm creating my own. And this is where we get into data marts. Different business units, marketing, finance, and possibly security, they're creating a sandbox of data, taking subset of the data that they want, that they are interested in, and they created their own data mart. And what we are seeing here, a lot of enterprises are getting a lot of data marts inside the enterprise. To give you the monetized value of the prediction and the big data and the data analytic and AI, let's get that hypothetical scenario. This school want to target some students, want to do some ads to get people applying to the school. So if they apply to 100,000 target customers, all of the customers that they have, they know that they are getting 10,000 customers. And every engagement when they target, like, they make a phone call, maybe an event, maybe send vouchers or print some papers, it costs them 10 dirham. So if they want to get all the 10,000 customers, if you do the math, they have to target or they have to send vouchers to 100,000 customers. Time 10, we're getting into 1 million dirham marketing campaign. So if they don't have that money, maybe they might target only 50,000 customers. But at the end of the day, what they're getting is 5,000 people to apply. So it's a linear because it's a very random. Now, and that will cost them 500,000. Now, what will happen with the prediction, we will change that curve. We will change it in that way. So instead of it's linear, we will know more the customer and will predict who will respond in a more accurate way. So that's the prediction effect. That's the machine learning effect. That's the data mining effect. So what will happen now, if they want to target only 5,000 customers, most likely they will need only 30,000 customers to target. 5,000 customers to apply, 30,000 customers to target. And that will cost them 300K versus the previous 500K. So a saving of 200,000 dirham in one marketing campaign. So the marketing team decided to create their data mart in order to do that targeting activity. Now, this slide is basically the same as the previous one. It's exactly the same. What I did, just I removed all of the vendor's name. I'm having the operational data or the source of the data. I'm doing the ETL, going to data warehouse, data mining, but I just reduce it to add more. Why? Because marketing team is trying now to get the ads and the log files from maybe the website. So what they did, they said, I want to correct the web clicks, like TRA, for example, they can collect the web clicks, try to understand your interest, what maybe videos that you are interested in their platform, and they collect the log files, maybe tweets about the platform, TRA Academy, or comments, Facebook, location, MongoDB. All of these are not really particularly structured, and this is welcome to the big data world. While everything here was structured like Excel sheet, rows and columns, now we're getting in a semi-structured way of data, like it's not really clear rows and columns. It's like maybe XML file, but it's not structured. Welcome to the big data world. And here in the big data world, we also extract the data, but we load it directly. We don't do transformation like we did in the structured data warehouse way. We just load it and load it to a super fast cluster. We call it Hadoop file system. In the Hadoop file system, think about it this way. It's basically a huge number of servers These servers have compute and the data. And when you send, let's say, 1 million log file, they will distribute, the Hadoop system will distribute the 1 million log line among all of these servers. Every server will process looking for maybe a word, interesting word like TRA Academy, which of these 1 million line of codes or logs has a TRA Academy. Every server will process it separately and then will conclude and they will add it together. That is the Hadoop file system. On top of Hadoop file system, and being Cloudera definitely being the most important vendor in the Hadoop space. So although it's open source, but Cloudera definitely is a major player here. So if you look at it, a lot have been built on top of the Hadoop HBase, which is a columnar database. You're talking about Solar text system. All of them is built on to that Hadoop file system. Massive parallel processing, lot of compute, lot of storage working in parallel to create the insight. You load the data here, and remember, we don't transform it. Why? Because transform it during the query itself. We don't do any modification. We put the data and let the cluster handle it. What happened more often that we're finding now that people are actually interacting by data warehouse, the structure, and the Hadoop file system. It's very expensive to put the data in the data warehouse. So people are staging the data into actually moving the data, archiving the data in a Hadoop file system because it's much cheaper. But at the same time, a lot of people actually doing some processing in the Hadoop file system and loading it to the data warehouse. So there is interaction between these two layers. And remember, this is to handle semi-structured data and unstructured data. But smart people observe that I have a lot of compute frameworks like Spark, Mahout, Hive, HBase, but it's the same data. So they thought of, why do I have that? Every server has a storage. Let me decouple it. And this is where we thought about it in 2010, where we came up with a platform called Isilon. We decoupled the data. Why? Because I keep my data in the same place, and regardless of which computing framework is running, I can access the same data. Spark, Yarn, TEDS, maybe HBase, maybe another distribution of Hadoop file system accessing the same data. And we will be loading this data into that file system. Now, the school got interested, especially with the COVID-19. They want to look at the video and social distancing. And maybe because of the e-learning, they want to understand the behavior of the students, which frame in particular video they are stuck at, they are repeating. So they said, we will actually put more data into the platform. So they pushed more data, more videos, more text, more audios onto the platform. Now, processing these data is a bit different than the structured and semi-structured data. It's massive and requires particular attention. And here we will welcome you to the world of deep learning. When we're talking about image processing, text processing, audio processing, it's by default, it's a deep learning. This slide shows you that I have a deep learning activity that I apply on the data. Previously or historically, it's smallly focused on unstructured data, the image and voice and audio, but more and more we're seeing the deep learning actually moving and eating some of the use cases of the machine learning, whether it's structured data or demand forecasting or fraud management. So machine learning, again, algorithm focused on structured data. Deep learning is trying, for example, object detection, face recognition, speech to text translation, speech to text writing, transcribing, maybe summary of text. All of this is the area of the deep learning. So, and we're seeing the deep learning actually extending to the machine learning. Now, there's a big advantage of the deep learning versus the machine learning. As the data size increase, the accuracy of the platform typically increase. While the machine learning, you reach a saturation point at any point, at certain point where you cannot actually improve your model. So just let's go back. You remember that diagram where we're talking about machine learning? You get data and output. You apply some algorithm or model to create the rules. Well, deep learning is exactly the same. The difference is these are layers and layers and layers of small algorithm or equations. We call it activation function. A lot of functions. If you look at it, I'm not sure if you can see it in the screen. This layer in particular, for example, 320 by 320 by 3, every one of them is kind of activation layer, a function like, you know, plus, minus, think about it this way to just super simplify it. And every single layer here is functions and functions. The latest one that we heard from Microsoft in the neural network, it's a GPTL3. It's a 170 billion function. It's massive, it's huge. So instead of just function 3a plus h minus, I don't know, s, no, we're 170 billion operation. And what's happening, you put the data here, you process it along with the output. So for example, if you have a picture of cat and a label saying this is a cat, the data is actually a picture, the output is actually the label, calling the data, sorry, the picture as a cat, you process it to create a rule. And you go through that 170 billion function in order to create it. That has put a lot of pressure in the compute power. And I want to just to give you a snippet or a sense of what is the required compute platform to do this. This is a CPU, Skylake processor, wonderful processor that's processing the images here. And this is exactly, I hope that you can see it the same speed. This is exactly what's happening here to process these images. It's around 4 images per second. Now you get into the world of GPU, and this is the speed that you get into it. More often, people are using the GPUs for modeling and training. And if you remember the inferencing, which is basically applying the model into the data itself, people are using more of a processor point of view. Well, I know that there is a debate between maybe NVIDIA and Intel and the best practices, etc. But the general practice on the field here is this is what we see. Modeling is happening, especially in the deep learning part, and the training is happening in GPUs, and the inferencing is happening in CPU. Things are changing, but this is what we have here today. So now we reach that, just to bring it back, operational data, structured, big data, unstructured, and semi-structured. Then you push it to a platform, data warehouse, maybe a Hadoop file system, and maybe a big repository where you put all other data. And then the GPUs will need a very fast. You can imagine if I have self-driving car, you need to process massive number of images. How to do that? GPU require massive bandwidth. And Iceland platform also served you in the past with the machine learning, with the big data, and it will serve you in the future with the massive parallel processing GPUs, streaming the data into the GPUs to do the model. Now, the school got very interested now. They said, well, we built that capability. We know how to extract data from the source systems, and we know very capable of loading it in the data warehouse. In fact, that streaming, by the way, sometimes they call it data pipeline, we are doing it automatically and load it every day in the data warehouse, but also we are collecting all the web clicks, all the log files from the school website, loading it in a Hadoop file system. We're doing processing, we are creating some insight, and also the media. We are extracting all of this at the same time. But we don't have the capability right now to do a real time. Meaning, if the student is logging into the video and I see her or him stuck in a certain video on a certain frame, I might suggest that student to go back and study another video. That is called a real time. Maybe while you are browsing the TRA platform, all the lovely videos that you have, they find you that very interested in a certain topic, but maybe you're stuck repeating some frame or some video more than one time. They can give you a pop-up when you, you're saying, oh, thank you very much. We recommend you to see that video because it has a lot of the information that you're looking for. Welcome to the streaming platform. So while the data is coming here, we want to treat this data in a different way. while the data is coming, flowing from the source, while I'm clicking my website, I want to capture this data. Yes, I will send it maybe to the Hadoop file system. Yes, the transportation will be sent maybe to the data warehouse or the exams data warehouse. But while the data is coming, I want to do something right now on it. Major players in the market here, you see Apache, Kafka, that's open source, and there's definitely some open source vendors who put an enterprise license for it or support for it. Kinesis also from Amazon AWS, that's one of it. So while the data is coming, I need to process it quickly and then create something, maybe as simple as, thank you. Thank you for joining, and thank you for the time that you spent. With this platform, this is what we call streaming platform. While the data is coming, you split the data, one path to be processed. Maybe you apply the model on it, process the data, and think maybe this is a fraud in the banking, for example, industry, when you do the ATM card withdrawal, that you can get sometimes deny transaction because they did the algorithm and they found out that might be a fishy transaction, so decline. That is a real time. This real-time capability is being added to the school now by adding also a streaming layer platform. Gartner called this Lambda architecture, if I'm not mistaken. I think that's the same term used in Gartner. It started with LinkedIn, but in Gartner best practices in data platform architecture, this is a Lambda architecture where you have a streaming layer, you process it now, and there is also the batch layer where you do the modeling, you take your time to create the insight. So think about it this way. This school started very simple, very humble. They wanted just statistics, results, commute time. Then they deployed, extracting the data, deployed it in a data warehouse, then they did the query and the visualization. Then they were more ambitious and they did some sort of prediction. I want to know the future. It's okay to get the history, but the history has, in many cases, doesn't predict what the future look like. So they went into the data mining exercise, and that got everybody in the school excited. And then the marketing team said, I want to build my own sandbox. So they built the data Mart. And after that, the marketing team got even more excited. And they built, they wanted to check the ads, they wanted to check the websites. So they got unstructured data, and they built the Hadoop file system to deal with the unstructured data. And then we found out that these guys wanted to go to the videos and imagings and audio, etc. So they want to deep learning. So they got GPUs, they processed the videos with the GPUs, and they got that deep learning capability. They got very, very excited, and they wanted to go to the real-time analytic. And this is where they built actually their streaming platform, where they push all of the data in one place, and then after that, processing. So having said that, thank you very much for the timing, for your time today. But I want to give you some reminders of what we covered. So we have the artificial intelligence. We defined artificial intelligence is just mimicking a person, act, sense. We talked about the machine learning. We said that the deep learning actually, in fact, part of the machine learning. And we said that the machine learning, you deploy a model in the machine learning versus traditional programming is just, if a statement and control statement. Data mining is enterprise practice that's leveraging machine learning to find pattern in the data. And then you have the extract, transform, and load to get the data. And remember, this is a very heavy exercise. 80% of your data project is spent in here. Inferencing is just applying the model that your data scientists spend a lot of time on that. Then they want to take that model and apply it in a real time, maybe, or even in a batch file. And then the data warehouse is a single point of truth. Remember, the big data is a volume, value, and variety. Data can be structured, unstructured, can be images, can be anything. So I'm trying to get here some of the questions, and thank you for posting this question. The first question, Khalifa Al-Marzouqi, thank you for the question. Can we consider RPA, robotic process automation, as AI? Indeed, yeah, that's actually one of the major examples of the AI, because it's not only mimicking the human when it comes, to responding, but also at the back end is using very sophisticated algorithm in order to do it. Some of it as simple as, Alexa putting, for example, in Alexa and Amazon, you put some statements, if then, but that's trying to mimic the human. But most of the RPA actually is very well equipped with very sophisticated artificial intelligence algorithm in the back end. How artificial intelligence in analytics support the cybersecurity defense? This is a very good question. Actually, many of the fraud management that we're seeing in the banking today, billions of frauds, at the beginning it was machine learning, and now they just put more and more features of the data. Remember, the features is, sorry, I didn't address that during the presentation, but features like, the attendance, the history, and the subject, this is feature. In a deep learning or machine learning, it could be hundreds of features. In the deep learning, it could be millions of features. So people, for example, in the banking, adding a lot of data and put it to predict the results. Now, I have seen actually people are going wild in the cybersecurity space by moving that cursor. You see, I'm moving my laser here, pointer in the screen. And by moving that cursor, they can draw a picture, pass it to convolution neural network, where it predicts that this is actually a malicious act. In the cybersecurity, is going actually wild. Many algorithms happening now to have a cybersecurity. What can artificial intelligence do with encryption? Well, that's particularly difficult question. If I think of encryption is in mathematical modeling, right? It's an algorithm that either symmetrical or asymmetric key, and it is a very structured in nature. You don't have that need, you don't have that philosophy of getting, for example, this is the data, this is the output, what we call it a labeling exercise to do encryption. So I don't think it's too much applicable here when it comes to the encryption. Faisal Al-Hamadi, do you recommend initiating a data project for a small and business? Well, I think data-driven organization, it doesn't need massive enterprise organization to be a data-driven organization. It could be very small shop. Yes, you can predict, you can find correlation, you can find pattern. Recommendation, definitely. We are heading to a world where data-driven organization is the default, where shops and organizations and companies will compete and beat competitors using data and insight. So the answer is definitely yes. Depends on definitely how the data, how much data you have, and what the data can help you with. So Khalifa, once again, Khalifa, a question about the cybersecurity. What artificial intelligence can do in the subject of unauthorized access to the data? This is a massive topic. Maybe if you remember the elephant picture that I put at the beginning, when we go actually to enterprises and talk about the data capability, immediately you'll find people are talking about the security, and the security aspect of it is massive. There is something called data lineage. I want to understand the source of the data, where the data is heading, who has created the data, who has consumed that data. I want to make sure that there is authorization, authentication, and access, and actually logs about who accessed the data. I want to do masking. Something is not only about security. It could be PCI compliant in the banking or HIPAA compliant in the healthcare. How can I hide and mask the data? This is a major topic, and definitely there are many solutions out there to address this particular problem. So that question, the second question here is about what you are talking about. That's ERB. I'm not sure I got that question. What about AI? So it's okay. connecting the ERP system. I didn't get the question right, but in general, ERP system can touch many parts of the organization, be it the finance, be it the HR, be it the supply chain, etc. And if you remember the very first slide, when you have a business model, whether it's a supply chain, whether it's the value chain, whether it's even a very high level competitive analysis in the industry, the recommendation is to consider the data at every single point. What data can be created and what insight can be created out of that. Definitely, there are a lot of ERP solution which has some capability when it comes to prediction here. So Ahmad, this presentation is related to big data, cloud computing, or AI. This is a very interesting question, Ahmad. So we are in we as a vendors actually are a little bit guilty in creating some sort of confusion and hypes for different terms. So previously it was long time back, analytic is a default in all organization, but historically analytic was focused on structured data warehouse. And then the term of big data, if I remember correctly, came maybe 2010, something like that, 2000, even before that, because the nature of the data, unstructured data. But at the end of the day, we want to do some sort of analytic on the data, but leveraging unstructured data. And then moving forward, the deep learning showed the world different capability by processing videos, audios, translation, and many capability at the compute level, at the algorithm level has shown up, and people start to think of really artificial intelligence. Artificial intelligence meaning same data, I want to create insight, but I have much more capability right now. So the terms are used, like, it's interchangeably. Now the term everybody is using about artificial intelligence. The bottom line, how to get insight out of the data to create actionable results. The presentation is same question from Ekra, and I think I caused some kind of a confusion here. So remember, AI, if you want academically speaking, artificial intelligence is something started very early in 1920 and 1930. So it's not something new. Artificial intelligence is a person, is a computer trying to mimic a person. That happened with the very first chess experiment when I don't recall the doctor professor name, he created an algorithm for the computer to play chess. That's long time back. So the term is not new, artificial intelligence. Moving forward, we started to see deep learning, machine learning, the regression kind of things, predicting the prices of a house, predicting the score of bank consumer credit score. All of this is a machine learning exercise. Some people are call it data mining within the organization, but data mining maybe it includes many processes, many best practices in a model called the CRISP. If you want to search it, please. That's a CRISP model. It's a very structured way of doing machine learning in organization. But at the end of the day, both of them create some insight out of the data. Under that is the deep learning. The deep learning is applying the same machine learning, but very massive neural networks processing really huge, massive amount of data. The excitement happening in the image processing, in the speech recognition, etc. But the same model in the deep learning can be also used to replace machine learning in many cases. Not better or worse, but it can do the same job that machine learning is doing. Now, nowadays, people, as I said, using the AI most of the time to refer the sophistication of the deep learning. So, Bassam, how we can avoid misuse data to manipulate the estimation and the prediction. This is another big topic. Remember, guys, we're going through the basic lot. I love the questions. This is a very critical question, Bassam, and thank you for this. And actually, it brings the topic of data bias. I think just yesterday or 2 days ago, MIT removed a data set, massive data set, from their experiments that people used actually for image recognition. Why? Because they detected some bias inside that data. race bias inside the data. So they removed it completely from the availability in the market. So the question is twofold, Bassam. One of them, the intentional, and one of them, the unintentional. And I'll give you an example. One of the bias of the data, and one of the banks in the US were trying to get prediction of the loans. I want to give some loans to some people. And part of their model was actually the zip code. So the problem with putting a zip code here, and you know, in different places in the US, certain race live in certain area. So that model that was created actually was a bias to against the black race. And then that zip code was removed, and I think today is mandatory to remove that zip code from anything related to the human, because it can have a correlation with the race. That is one. Another major problem that we are having today, and but by the way, the state of the art of the AI, they're doing very, very well now in detecting that bias, especially the race bias in there. So how can we mess using the data to manipulate this machine? Yeah, the second part of the question is that injecting that bias. That is difficult, because if you have someone intentionally doing that bias, well, you can track the logs, you can track the results, you can track the model. And remember, we don't do actually modeling and then apply it. No, we do testing, we do validation, we do co-validation, and the normal practice today actually is to share your model to see if another data science can deploy it again. So that transparency in the model is a best practice across all of the enterprises today. Maybe another challenge of the part that you asked, sorry, but some of your questions really wide, is explanatory of the deep learning. If you remember, we said there are some models that have 170 billion parameters, versus the model that we built together, it was 3 parameters in the school. It was the attendance, it was the history, it was the subject. So I can explain in my model that we built it together, I can explain why people pass and why people fail. But if you go to a model which is 170 billion parameter, it's a very difficult to explain. And this is a huge and massive part of the AI research, which is called explanatory analytic of the AI. So Ahmed Abdullah, why we use the deep learning if machine learning are so useful and basic? It's another very good question. Well, machine learning is very good in many things, but one important difference between machine learning and deep learning. Machine learning, you can apply maybe 100 features. Like, you know, if you're talking about credit score, for example, in a bank, my age, my income, how many kids I have, when I got married, do I have people? And there are some features, but counted features. And maybe I have a good number of data entries. But the thing is, as these features increase, think of an image. Image is a 1,000 maybe pixel by 1,000 pixel. Every single pixel is a feature. That's a 1 million. So the traditional machine learning, remember, deep learning is a subset of machine learning. The traditional machine learning cannot address that, cannot get really the parameters and calculate for the parameters value of a 1 million pixel. And this is why we're getting into the deep learning and the neural networks. The second big difference between machine learning and or traditional machine learning and the deep learning is that in machine learning, it tends to saturate. So you reach a point where no matter how much data you add, you cannot improve the prediction. In deep learning, what we found out is that you add data, you improve the prediction. Actually, sometimes you complicate or you get the network bigger, you get more accuracy in the model itself. Why we use the deep learning if machine learning is so useful? But just don't get me wrong, Ahmed Abdullah, a lot of people actually are very happy applying machine learning again, because one important part, which is the explanatory. because I can explain why I am predicting this particular result. In deep learning is a bit difficult. If you go to deep neural networks, it's a bit difficult to explain it. What is the role of AI in big data? I think I look at them as very complementary terms. So the big data is, as we said, it's the volume of data, the nature. It's a term that's used to explain why we have now data that is difficult to process. McKinsey at a certain point of time defined the big data as all the data that produce a challenge to today's technology to process. And I love the definition because it's a moving target, this definition. For example, 5 years ago, it was maybe very difficult to process a high definition video and do some analytics on it. Today is doable. So that the big data is a term explaining the nature of the data and the challenge coming from the big data. AI is the mechanism to process this data and to create some insight out of it. How to learn more about AI by simple method and resources. Well, I'm a very fan, and I think I recommend everyone, and if you want to have a very high understanding of the AI, I highly recommend Coursera, Andrew NG, AI for Everyone. And Andrew NG, I think he came here to UAE and he did some wonderful sessions. So that is the basic. This is a wonderful course to start, and it doesn't need really technology. It's for everyone, for business leaders, for business owners, for students to get into the track in a very high level. If you want to get deeper, I recommend also, again, Dr. Andrew NG, Stanford University. The other course is called Deep Learning AI. There are thousands of courses, guys, out there, but this is what I felt. I did a lot of them, but I felt this is actually a wonderful course for people who want to start and people who want to get a little bit deeper. How artificial intelligence can help in medical field? Wow, so that's a great question. How does it help in the medical field? What we are seeing now, if I'm mentioning example quickly because we have 3 minutes. COVID-19, today there is open source. I tried it myself. Open source data to get your MRI and the scans and predict whether it's a COVID-19. If God forbid, any one of us has some sort of difficulties in breathing, you can get the MRI even without having COVID-19 test. You can predict with some accuracy whether it's a COVID-19 or maybe pneumonia or SARS or anything. I mean, God forbid, no one will need that, but it's available in the open source. MRI analysis. I'll give you a quick example. Retina. Many people might face retina detachment at any point of time, and it required actually specialists to understand the image and to understand whether this is predicted to be detachment in the future. And detachment is a very serious thing in the vision. And 2 universities came together along with hospitals, and they got the input for 200,000 images with many practitioners. And the accuracy of the model to predict retina attachment from the image was something like 97%. That's even better than many of the professionals out there in the practitioner. So by definition, medical field has a lot of data, has the MRI, has the X-ray, has the vital signs that you can collect nowadays from IoT devices. If you combine all of these data, you put output, you can create a model to classify and predict maybe certain diseases or diagnosis. So it can be helped in prognosis or diagnosis a lot, and there are many, many cases in there. If you go, again, I mentioned Coursera, you go to Johns Hopkins School, a lot actually in genome sequencing, bioinformatics, a lot happening there in the data science and the machine learning. I have 1 minute left. Why we still can't see good success story for using AI? Not sure, Sahar, if I would agree on that. We're seeing a lot of success stories in the AI, but what I will agree with you is taking that success and making it operational that is a challenge. So we were not seeing a lot of people actually doing that. And that is, will take us to another thing. A lot of people are doing data platforms. I didn't touch on that. Data platform, which means operationalizing the insight of the data science and taking it to operation to benefit the business. Having said that, I would like to thank you very much. A lot of good questions, a lot of insight. Remember, this was a basic session. I'd like to see you more, maybe to deliver in depth in a particular area that of your interest. Thank you very much.